All right, let's talk about password hashes. So if you can go to an online calculator, or you can use Kane enabled to steal passwords from a Windows machine. And anyway, Windows passwords are not salted. The same input password will always turn into the same password hash, and the most famous password of password has a hash starting with 88. It's not very long. It's using a very out-of-date algorithm. Microsoft has never updated this thing in 25 years. So, in fact, it's so out of date that the hash library you need is not included in Rust anymore. You have to go download it to a special crypto library to get MD4. MD4, this hash, Microsoft developed this hash in 1993 for Windows NT, and at that time, MD4 was the best available hash algorithm. MD5 had not even been written yet, and they just never updated it. So anyway, you do these commands to install the crypto library of MD4, and then you can make a program to calculate a hash. So here's the program that does this. You import the MD4 library, which has a sort of long name because it's not one of the standard libraries, and the format library. And now you define a string to be a password, and here's how you use it, which is the same in many other languages. You create a new MD4 object, then you write in some bytes, and then that creates an object that includes the hexadecimal hash in addition to other things. And you take the this function to get the hash you want and put it in a variable called BS. And then you just print that out. So this will give me the MD4 hash of the password. And that's #1. All right, so it calculated the hash. The only problem is it's wrong. It should have been 8846, but it's 8A9D. So the hash algorithm is okay, but something is wrong. And what's wrong is the character encoding. Microsoft, even from 1993, was an international operating system. They wanted to support all the commercially important languages like Hebrew and Arabic and Chinese and everything. So you can't put one character in 1 byte anymore. Instead, you need to make it longer. Now, again, at that time, all Microsoft could do was use really old stuff. And what they used was this really old system called 16-bit Unicode. That turned out to be a mistake because even 16 bits are not enough to encode all the Chinese characters and all the characters you need. So in the modern world, we use UTF-8, which can go up to 4 bytes per character. But in the Microsoft land, passwords are encoded with 16-bit Unicode, and I couldn't find any native way to handle that in Go. So this program called #2 uses a sleazy hack. So I start with the password, and then I go through a loop of every character in the password, counting, and the C is the character, and then I just add that character's 1 byte, and then I just manually add a null byte after each one. So this is not going to work for general 16-bit Unicode characters. It's just going to take normal ASCII characters and add the missing null bytes to correctly encode them in Microsoft's 16LE system. And then the rest of it works the same. So if this is right, I'll get the correct hash for password. And so that's #2. And as you see now, it's the 8846 I expected. And I printed it out. It's 8 runes long, and each rune is 2 bytes. Runes are what Go calls these characters. Modern characters are not just 1 byte. They are a character that might be a hamburger or a Chinese character or anything like that. And so they call it a rune in Go. All right. So now there are just some challenges to calculate the NTLM hash of this thing and crack a hashed pin, find the pin containing ADA, and so on. There's some various challenges here with various kinds of hashes you can crack, and you can crack them with Go. So I'm going to stop this one.